and today we're covering the digestive system. Now I will divide this lecture into two parts because it's a really long PowerPoint, right? So let's go ahead and begin. Function of the digestive system include taking food, break it down into nutrient molecules, absorb molecules into the bloodstream, and get rid of any indigestible remains. Digestive system is made of two groups of organs, and the first is alimentary canal, or what is called a gastrointestinal or GI tract. And that's pretty much a tube from your oral cavity, from your mouth to the anus. Alimentary canal digests and absorbs food, and it's include mouth, pharynx, that's what you call a throat in everyday English, esophagus, stomach, small intestine, and large intestine. And the second group of organs are accessory digestive organs that will assist in digestion and absorption. And they will include teeth, tongue, gallbladder, and digestive glands, salivary glands, liver, and pancreas. So here we can see anatomy of the digestive system, including our GI tract and accessory organs. So you can see we're going to start over here with mouth or oral cavity, where you will find your tongue, that is accessory organ. Hold on a second, I think. Yeah, I want the pen that disappears. So again, oral cavities, then tongue is accessory organ, salivary glands, accessory organs, including parotid next to your ear, sublingual, below the tongue, and submandibular, below the mandible. Then we have pharynx, esophagus, stomach, small intestine that is divided into three parts: duodenum, jejunum, ileum, and large intestine. We call large intestine colon. So we have cecum, that's the first part of the large intestine. Then ascending colon goes up, transverse colon, descending colon. Then it makes this like a curve, C shape, that's a sigmoid colon, rectum, that means straight, and anal canal, and anus. That's part of the large intestine. So we already mentioned some accessory organs such as tongue. Of course, you have your teeth, salivary glands. Other accessory organs include liver, gallbladder, and pancreas. Peritoneum is a serous membrane of the abdominal cavity. And as any serous membrane, it has two layers: visceral peritoneum on external surface of most digestive organs. Shown here, all peritoneum here shown in green color. So for example, this green structure covering liver or stomach or small and large intestine, that's a visceral peritoneum. Parietal peritoneum lines the body wall. So if you see here, we have another, like this layer that covers the abdominal wall. Peritoneal cavity is between the two peritoneums, and fluid in the peritoneal cavity is serous fluid. It lubricates mobile organs. Now, the five major peritoneal folds include a greater amentum. It's an apron-like structure that lies superficial to the small intestine and transverse colon, a site of fat deposition in people who are overweight. Falciform ligament anchors the liver to the anterior abdominal wall and inferior border of the diaphragm. Lesser omentum suspends the stomach from the inferior border of the liver, provides a pathway for structures connecting to the liver. Mesentery is a vertical band of tissue anterior to the lumbar vertebrae and anchoring all the small intestine except the initial portion, the duodenum, to the back wall of the abdominal cavity. Mesocolon attaches two portions of the large intestine, transverse and sigmoid, to the posterior abdominal wall. So we mentioned that peritoneum is a serous membrane, right? And peritoneum covers viscera, organs in the abdominal cavity, and the cavity itself. Plus, the peritoneum make major folds, right? So that's a membrane that makes all this structure that we just discussed. And now you can see the picture. So that's a greater omentum over here. So it attaches to the stomach and it covers the anterior wall of the abdominal cavity. So it actually covers your entire small and large intestine, and it accumulates large amount of fat, right? So here we can see greater omentum again, right? So here's a structure that hanging down from the stomach, and lesser omentum is on the lesser curvature of the stomach, right? That's that attaches stomach to the liver. Then falciform ligament is this ligament that separates right and left lobe of the liver. And that's a very beautiful picture over here of the mesentery proper that attaches to the small intestine. And what it does, it holds your small intestine in place and also attaches it to the back wall of the abdominal cavity through the root of mesentery. Blood supply of the digestive organ includes arteries, hepatic arteries, splenic, left gastric, inferior and superior mesenteric. So here's our aorta. And then from aorta, we have a small branch over here called celiac trunk. And from the celiac trunk, we have branches that goes to liver, hepatic artery, to the stomach, gastric artery, to spleen, splenic artery, to the pancreas, right? So that's from celiac trunk. Then another branch from aorta includes superior mesenteric artery that supply again pancreas, small intestine, and part of the large intestine. And inferior mesenteric artery supplies the rest of the large intestine. So those are our artery. We bring oxygenated blood to the digestive organs. Now, we pick up waste product from the cells of digestive organs, and also what we pick up, nutrients, right? So we pick up nutrients by veins, and those veins specifically, they bring blood to the liver first, right? So you pick up oxygenated blood, but this blood rich in nutrients because you pick up blood from small intestine over here. And you take this blood to the liver. Now, this pathway from digestive organs to the liver is called hepatic portal circulation. It drains nutrient-rich blood from digestive organs and delivers it to the liver for processing. Now, after you process those nutrients by your liver, you have hepatic veins that take this blood from the liver to the inferior vena cava. Now, hepatic portal vein is not the same as hepatic vein. So in the hepatic portal vein, you have blood from digestive organ before you process all the nutrients. And in hepatic veins, you have blood from the liver to the inferior vena cava after you process the nutrients by liver, remove some toxins or maybe some medication. some drugs, you store some nutrients in the liver, and then that blood is returned back to the circulation through hepatic veins. So here's another anatomical diagram, because the first one was more physiological diagram. Here you can see our celiac trunk that I already mentioned. In anatomy, trunk means short blood vessel and three major branches: left gastric, splenic, and common hepatic, that brings blood to liver, spleen, I'm sorry, liver is right here, stomach, spleen, liver, gallbladder, pancreas, and the beginning of the small intestine. Histology of the alimentary canal. Of course, we will see varieties because your stomach and small intestine, they have similar functions, but not exactly the same. So we will have some varieties in the histology, but the main layers are the same. So we're going to start from inner and we go to more superficial. So we're going to start from the lumen and we move to the superficial layers of GI tract. So first, mucosa. It's an epithelial tissue that underneath of epithelium, we have lamina propria, that is connective tissue, and we also have a small amount of smooth muscles in the muscularis mucosae layer. So here's our epithelium. So it can be most of the epithelium is simple columnar. Then lamina propria and muscularis mucosae layer, that is layer of smooth muscles. Then submucosa. So over here we have layer, a pretty thick layer of submucosa that includes blood and lymphatic vessels. Oh, I'm sorry, it's not that, it's just this one. Just this one over here, that's a submucosa. And then we have muscularis. Yeah, so the muscularis is the thickest layer. Now, muscularis tells you that's a layer made of smooth muscles. It's a double layer that is made of circular muscles, as it goes this way, and longitudinal muscles that go along the GI tract. And serosa, it's a superficial layer only present in abdominal cavity and holds alimentary canal in place. Now, if you look, for example, at the esophagus is not covered by serosa because it's not in the abdominal cavity, so it's covered by adventitia. But both serosa and adventitia, so adventitia is connective tissue. Serosa is made of areola connective tissue and epithelial tissue. Now, if you look at the previous diagram, let me go to the previous diagram. It is those nerves over here. And on the next slide, we have two plexuses. Plexus is a network of something, right? So if it's neural plexus, then it's network of neurons. Now, these plexuses are called enteric nervous system. It's intrinsic nerve supply of the alimentary canal. We have submucosal, submucosal plexus that regulates gland and smooth muscle in the mucosa. So remember, we have our mucosa, then we have submucosa. And in the submucosa, we have submucosal plexus and myenteric nerve plexus. Now, mya means muscle. So that's a plexus that located between two layers of muscles. Right, so remember we had this circular, we have longitudinal, so, and we have this mesenteric plexus that controls GI tract motility. So submucosal controls glands, mostly glands, and mesenteric, the contraction of your GI tract. All right, now we will look into more details, and we describe the major organs of the GI digestive system. Now, in this video, we only cover organs of GI tract. In my second video, we will cover accessory organs. So we're going to start with mouth. We have oral or buccal cavity that is bounded by lips, cheeks, palate, and tongue. It lined with stratified squamous epithelium and contains orbicularis oris and buccinator muscles. Right, so here it is a picture of a mouth and oral cavity. This is a mid-sagittal view of the oral cavity. The roof is made of hard and soft palate and uvula, and the floor is your tongue. You have teeth, and posterior to the oral cavity, you have oropharynx. Also, in the oral cavity, you have palatine tonsils and lingual tonsils. So here's the palate that we just mentioned. Hard palate is made of palatine bones and palatine processes of the upper jaw of maxilla. So this is mid-sagittal view, and what color here in red? This is part of maxilla. So that's a palatine processes. And then the, I think it's still red. So the posterior part are palatine bones. So it's slightly corrugated to help create friction against the tongue. Then we have soft palate, formed mostly of skeletal muscles, closes off nasopharynx during swallowing, and uvula protects downward from its free edge. Projects, and uvula projects downward from a free edge of the soft palate. So you don't have uvula over here, but it would be right there. So hard palate, soft palate, and then uvula. Tongue function includes repositioning and mixing food during chewing, formation of the bolus, initiation of swallowing, speech, and taste. Intrinsic muscles change the shape of the tongue. Extrinsic muscles alter the tongue's position. And lingual frenulum is attachment to the floor of the mouth. So if you look over here, that's a dorsum of the tongue, and you can see intrinsic muscles such as styla, glossus, all muscles that related to the tongue over here will have this glossus part in their name, so that will be our intrinsic muscles. So styla, glossus, hyoglossus, that's a hyoid bone, and a gena glossus from the chin. So that's make your tongue. And then you can see over here, this is genohyoid muscle. That is the extrinsic muscle of the tongue. Extrinsic salivary glands. So we have 3 pairs of larger glands and several smaller glands that produce saliva. Now, parotid gland is anterior to the ear, external to the masseter muscle. So here the ear, so it's anterior to the ear, and this muscle over here is a masseter. So it's external to the masseter. Parotid duct opens into the vestibule next to second upper molar. So here's the parotid duct. Then submandibular gland medial to the body of mandible. So it's located right here. Duct opens at the base of the lingual frenulum. And lingual frenulum, so if you open your mouth and you lift your tongue, you will see like a little fold holding your tongue to the floor of the oral cavity. That's a lingual frenulum. Sublingual gland anterior to the submandibular gland, so that's sublingual, under the tongue, and opens via 10, 12 ducts into the floor of the mouth. Intrinsic and buccal salivary glands, those are smaller glands. They are scattered in the oral mucosa. And all this gland, buccal gland and the glands that we, extrinsic gland and intrinsic gland, they produce saliva. Saliva cleanses the mouth, moistens and dissolves food chemicals, aids in the bolus formation, contains enzymes that begin the breakdown of starch. Teeth. Also, by the way, your salivary glands are accessory organs. So yeah, I told you before that I will only cover GI tract, but yeah, some accessory organs that are located in your oral cavities and salivary glands, I guess we're covering as well. So what teeth do we have? We have incisors, oops, that chisel shaped for cutting, canines, fang-like teeth that tear or pierce, premolars, or another name bicuspids, and molars. They have a broad crowns with rounded cusps for grinding or crushing. So here the deciduous teeth or milk teeth, what we call it. So we have incisors, then we have canines and molars. And when we get older, we have permanent teeth. So again, incisors, canine, premolars, and molars. And you can see they look different. And they have different structure because they have slightly different functions, some for tears, some for chewing, some for cutting. Now, we use dental formulas that indicate the number and position of teeth. It's a ratio of upper to lower teeth for half of the mouth. So they pretty much divide your teeth into 4 quadrants. All right, that's why you, so upper teeth, you have half and half. That's why you multiply by 2. So total give you either 20 teeth if we're talking about primary, or so that's your deciduous teeth, and or 32 if we're talking about permanent teeth. So that's so on the top you have half of the upper teeth, and on the bottom you have half of the lower teeth. So you multiply by 2 to get your total number of teeth. And the same for permanent. On the top, we have half of the upper jaw teeth, and on the bottom, we have half of the lower jaw teeth, and we multiply by 2. So we have 2 incisors, 1 canine, 2 premolars, and 3 molars. Right, so if you look like, okay, so how many canine I have in my upper jaw? You have 2 in the upper jaw and 2 in the lower jaw. So premolars, you have total in the upper jaw 4 premolars and in the lower jaw 4 premolars, right? And you have 6 molars in the upper jaw and 6 molars in the lower jaw. So if you go back over here, so what they do is they kind of, so let's say this is the upper jaw, so they divide it into half, right? And here's your half of the upper teeth. So you have incisors, you have 2, then you have your canine 1, right? But because you have 2 on the right side and 2 on the left side, so total are 4. Then you have 1 canine on the right and 1 canine on the left, so there's going to be 2. Then 2 premolars or bicuspids, so total 4, and 3 molars, so total 6. Anatomy of a tooth. So tooth is made of crown, neck, and root. Crown is portion above the gum line, and it's covered by enamel. Root is embedded within maxilla and mandible bone. So here's would be the root. And the root, this part over here is made of dentin. And it's attached to the socket through periodontal ligament. Then we have pulp cavity, that is a loose connective tissue. So right here, this pulp cavity, loose connective tissue that contains blood vessels and nerves and surrounded by dentin. So here, that's our surrounded by dentin. Okay, so now we're moving to the pharynx. That is involved in digestion and respiration, runs from posterior oral and nasal cavities to the opening of the esophagus and larynx, and divided into 3 parts: nasopharynx, oropharynx, and laryngopharynx. So here's the nasal cavity. Posterior to the nasal cavity, we have nasopharynx, from posterior nasal aperture, that is this part, running inferiorly to the end of uvula. So here's our uvula that's hanging down from the soft palate, and that's the end of our nasopharynx shown here in red. Now that's the oral cavity. Posterior to oral cavity, we have oropharynx. So from the end of uvula running inferiorly to mid epiglottis. So that's cartilage over here is epiglottis. So if you find the midpoint about that, till this part, we have oropharynx, and the last part, the most inferior part of the pharynx, is laryngopharynx, from mid epiglottis to inferior aspect of cricoid cartilage. And cricoid cartilage is this one. So here is the anterior part, and this is posterior part. That's a cartilage of the larynx. So that's your larynx, voice box. So it's to the end or inferior aspect of this cricoid cartilage from mid of epiglottis, shown here in green. Then we move to esophagus. It's a muscular tube, posterior to trachea, passage of food, and it has upper esophageal sphincter and low esophageal sphincter. Esophagus lined by stratified squamous epithelium. So here we have our oral cavity. Then anterior to this structure here, that's a part of respiratory system. So we have larynx, we have trachea. Now posterior to larynx and trachea, we have esophagus. And of course, esophagus also divided into different parts. We have cervical esophagus, upper thoracic esophagus, mid-thoracic esophagus, and low thoracic esophagus. Now, esophagus then pinches through the diaphragm, so it moves from thoracic to abdominal cavity through this esophageal hiatus and connects to the stomach. So here's our esophageal gastric junction. Stomach. Stomach has 4 regions. Cardia, that's the area where esophagus and stomach connects. Upper portion called fundus, the main portion called body of the stomach, and the last part of the stomach is pylorus. Also, stomach has a greater curvature, so that's a greater curvature, and lesser curvature. So remember what is attached to greater curvature? Greater omentum, and lesser omentum attached to the lesser curvature. Now, stomach is a muscular organ, and we have 3 layers of smooth muscles. Inner is oblique, allows stomachs to churn, mix, move, and physically break down the food. So we have oblique layer, that's the deepest layer, then circular and longitudinal. So that's some modification, because remember when we talk about histology of GI tract, most of the GI tract has only 2 layers of muscles, circular and longitudinal, but stomach has extra inner oblique layer. Gastric glands are glands of the stomach. So if you look at the stomach, so here's, for example, the surface, then you will see like those like little indentation, like a little holes that go deep down. It's called gastric pits. And at the end of a gastric pit, you will have a gastric gland. So here's a gastric gland that kind of continues with this pit. So here's gastric pit and then gastric gland. So we have different type of cells in these gastric glands, but the major cells are parietal cells that produce hydrochloric acid and chief cells that produce pepsinogen. Now, pepsinogen will be activated, and to activate pepsinogen, we need hydrochloric acid, and it became pepsin. And then pepsin is the enzyme that digests proteins. All right, so here's the, you can see chief cells, the most numerous cells that gonna produce pepsinogen. Those are parietal cells for hydrochloric acid production. And we have enteroendocrine cells, so shown over here, that secretes hormones, endocrine hormones that regulate the function of stomach. They regulate the production of pepsinogen and hydrochloric acid and contraction of the stomach. So here's our gastric gland secretion, parietal cells secretion of hydrochloric acid that make a pH very low, 1.5, 3.5, and denature protein in food. So it's pretty much breaking those proteins by this chemical. Also, hydrochloric acid activates pepsinogen, and activated pepsinogen became a pepsin and kills many bacteria. Another important part that parietal cells secrete is intrinsic factor. It's a glycoprotein required for absorption of vitamin B12 in small intestine. And chief cells secrete inactive enzyme, pepsinogen, that is activated to pepsin by hydrochloric acid and by pepsin itself, a positive feedback mechanism. So the more pepsinogen the more pepsin we have, then this pepsin start activating pepsinogen. That is pretty interesting. But hydrochloric acid is very important for activation of pepsinogen. Mucosal barrier. Now, in the stomach and in the small intestine and in the large intestine, you have mucus, but we have especially a thick layer of mucus in the stomach. Why? Because we have very low pH. So that means it's very acidic environment. So mucosal barrier protects from self-digestion, well, because you make pepsinogen and pepsin that digest proteins. And if you look at the muscles are made of protein. So you don't want to digest your own muscle of the stomach. That's why this mucus will protect from self-digestion. It's also bicarbonate-rich mucus. So it will protect you from low pH. We have tight junction between epithelial cells. So here's our epithelial cells of the stomach, and here's our tight junctions, and stem cells that quickly replace damaged cells. All right, so what do we see over here? We have our gastric mucus cells that produce lots of mucus. They connected through tight junction, and that mucus is rich in a bicarbonate. So here's the bicarbonate. And what bicarbonate does, it's neutralize acid. So here's your mucus barrier. Then again, the major function is to protect from self-digestion and protect from low pH or high acidity in the stomach juice. Then we move to the small intestine, a major organ of digestion and absorption. So digestion and absorption mostly happens in the small intestine. Very little happens in your stomach. Small intestine is 6.5, 13 feet long from pyloric sphincter, and pyloric sphincter, it's a sphincter between stomach and duodenum. So first part of a small intestine, and to the ileocecal valve. The ileum is the last part of the small intestine, and it connects to large intestine, and it has a valve in between. Now, sphincter and valve, they have similar function. They both prevent backflow of substances. So this sphincter, pyloric sphincter, prevents chyme, so this partially digested food, from going back to the stomach, and ileocecal valve prevent the chyme that is in the large intestine backing up to the small intestine. They just have a little bit different structure. That's why it has different names. Sphincter is the circular muscle, and valve is more like valve you have in the heart. So it's not as concentric muscles. Now, subdivision of small intestine include first part, duodenum, that is 10 inches long. It's retroperitoneal. That means it's an abdominal cavity, but not in the peritoneal cavity. So it's behind this peritoneal membrane that we already discussed. The second part is jejunum, 3 feet, attached posteriorly by mesentery, and ileum is the longest one, 6 feet, attached posteriorly to mesentery as well. So here's the duodenum, the first part, the shortest one, jejunum and ileum. Now, jejunum and ileum, all those tubes are attached to each other through the mesentery proper, and mesentery attaches everything to the back wall of the abdominal cavity. So small intestine has unique mucosa and submucosa features. such as circular folds. So if you look inside the lumen, right, you will see those circular folds, and inside those circular folds you have villi. So that's a villus. Here's another villus, and villi are made of columnar cells with microvilli. So here shows us a one circular fold with the villi. So here's the villi. So here's one villus. Here's another villus. And then you see those structure over here, that's a simple columnar epithelium. So if you take a little part of it and you magnify, those cells have a microvilli. Those microvilli called brush borders. Now, why do we need all these features? We need them to increase the surface area. And by increasing surface area, we assist in digestion and absorption. We have also intestinal glands that secrete intestinal juice, and duodenal glands in the duodenum, the first part of the small intestine, that are very important not only in, so this one is important in neutralizing the acid that will enter small intestine from the stomach. So when your food is in the stomach, we call it chyme, and it's chyme mixed with hydrochloric acid, so it's really very acidic. So when we move to the duodenum, we need some neutralization of this acid. And we have a mold. Now, mold is mucosa-associated lymphatic tissue that has immune function. So if you look over here, so we have mucosa, then we have submucosa, then we have muscularis, right? And here's our, the mold will be found in the walls of the small intestine, that you will find lymphatic vessels right over here, and a lot of white blood cells that help with immunity. And a large intestine, the four major functions of the large intestine are reabsorption of water and mineral ions such as sodium and chloride, formation and temporary storage of feces, maintaining a resident population over 500 species of bacteria, and bacterial fermentation of indigestible materials. So what it saying over here is that most digestion and absorption happens in the small intestine. In the large intestine, we have just pretty much fermentation of indigestible materials and reabsorption of water. So we don't have lots of digestion or absorption in the large intestine. So large intestine, anatomy of large intestine is described over here on the slide. So the first part is cecum. It's the first part of large intestine, and appendix is attached to the cecum. So ileum connects to the cecum, and between ileum and cecum we have ileocecal valve. Then colon, divided into ascending, transverse, descending, sigmoid, that will be this part, and a rectum is a final 8 inches, and anal canal that is 1.5 to 2 inches. Anal canal has internal and external sphincters that prevents you from passing feces. Right? The internal sphincter is made of smooth muscle and external from skeletal muscle, so you can control external sphincter. Ascending colon and descending are retroperitoneal. So again, The organs are divided into peritoneal, that they are surrounded by this serous membrane called peritoneum, or the one that is not covered by peritoneum. Those are retroperitoneal organs. Now, transverse and sigmoid colon are anchored via mesocolon. So here's the transverse colon, and this is our mesocolon. And this is a sigmoid colon and sigmoid mesocolon. So now this is small intestine, and small intestine is attached to the wall by mesentery. Rectum and anus. Rectum has 3 rectal valves that stop feces from being passed with gas. So here's the rectum, and that's our rectal valve shown over here. Then anal canal, that is the last segment of the large intestine. So here's the anal canal. Anal canal has internal anal sphincter that we already mentioned, made of smooth muscles. So internal anal sphincter shown right here. So that's the set of muscles right there and here. And external anal sphincter shown right there. It's a skeletal muscle, so that's under voluntary control. We have superficial venous plexuses of the anal canal that can form hemorrhoids if inflamed. So you can see lots of veins here, very superficial. So when we have inflammation, they can protrude and even can protrude through the anal canal to the exterior, and this might be a very painful condition, and plus they can bleed. Now, large intestine has unique anatomy, some unique structure. One is tinea coli. So this is this smooth muscle band. It's a band of smooth muscle. It's made of longitudinal layer of muscularis. So remember, when we look at histology, we said we have mucosa, submucosa, then we have muscularis. Muscularis, we have a circular layer of muscles and longitudinal. So in the large intestine, we don't have complete longitudinal layer. What is left are actually these tinea coli. And tinea coli divides large intestine into haustra. Those are pouches. And the pouches result from tonic contraction of this tinea coli. So here you see a pouch, here's another pouch. So that's very unique features. And epiploic appendages, shown here in the yellow color, fat-filled sacs with really unknown purpose. Okay, and this is where I'm gonna to stop. No, it's like, oh, we didn't expect it. I think you're gonna continue. Yeah, I will record the second video because this PowerPoint, as I already said at the beginning, is very long. And believe me, I don't want this lectures to be that long, but I need to cover all the material. So if you finished watching this video lecture, you rock, right? Thank you so much, and I hope it was helpful.